Hello and welcome back to the shop. I've just been reviewing some of the comments on the YouTube video that I put up about the testing of the floating Reamer holder. And some very interesting comments. A lot of thought obviously gone into them. There's a lot of experience and knowledge of the people who have been giving these comments, so it's very much appreciated. It really is appreciated, and it made me think as well. There's definitely an error in the way I was using the telescoping gauges and transferring that information to the micrometer. And I thought what I'd do today is I'll just come in the workshop. I just want to check, go over the measuring, because I've still got the pieces here and I've still got them labelled up 1 and 2. Got two holes here. Got one piece in the vise here. But what I thought I would do is have a look. Just start off checking the micrometer, the 0 to 1 Moore and Wright micrometer, and it is a very good micrometer. And I've just checked it with my slip gauges. Now my slip gauges, I don't have anything that's calibrated like most people in the home workshop, model engineers or whatever. We don't, nobody has the stuff calibrated. You work in industry, you're working on nuclear submarines, you're working on aircraft, yeah, everything's calibrated, everything's recorded. Everybody knows exactly what standard the measuring equipment is in. But in your home workshop, nobody does that. I don't have any calibrated slip gauges or anything else. I've got an old set of slip gauges here. There's a date in here. It says 17th of June 1953. So these are pretty old. And a company of mine called Matrix. I don't know much about them. But they were something to do with commentary. They were in commentary, I think. Anyway, I've got some slip gauges, and in one of my micrometer boxes here, and I'll just bring you down so you can see this. This is an outside micrometer set, and it's made by a company called Ambrose Shardlow and Company Limited, Sheffield, England. Now I don't know if these were the forerunner of Moore and Wright, or they were bought out by Moore and Wright, I'm not sure. But they certainly had something to do with Moore and Wright in later years. But they've got a 0 to 4 inch external micrometer set. What you have to do is change the anvils. Now this set was in a pretty bad condition when I got it. There was damp and stuff had got into it, so some of the anvils were in a pretty rough condition. But they can be readjusted. You can adjust them to set your zeros or set your whatever size you want to set them to. But anyway, I'll just show you what these are. I should bring you down and you can see. There you go. Good thing about this is if you were going on site and you weren't sure what size micrometer you needed for measuring, say, a shaft or something like that, you could take this with you, and you could, if it was a 2-inch shaft, you'd be able to cover that. If it was a 3-inch shaft, you'd cover that. You wouldn't have to take a 0 to 1, 1 to 2, a 2 to 3, and a 3 to 4. Just take this one set with you. But anyway, there it is. But inside the set, I've got a standard, and it's a 1-inch standard. I've also got a 2-inch standard there. So I can use this. I can check this against the micrometer. And I haven't made any adjustments to the micrometer at all. I've never touched it, to be honest with you. So we can use this standard, and we can check our micrometer against this, and then we can check with a 1-inch slip gauge. And I've also checked it with a 1/2-inch slip gauge and a 200,000 slip gauge, just to see if there's any discrepancies throughout the range of its measuring capabilities. So that's a 1-inch standard. We're going to check that now. Okay, right, so what we'll do, just get our micrometer to my hand now. Let's just make sure this is clean. It's surprising, just a little tiny speck of dust or whatever changes the dimension. There you are. It's 1 inch. I'm going to try and do this without damaging anything. Can you see? Don't know if you can see that. Let me bring the camera down so you can see. Easier down here, I think. So that's 1 inch. 1 inch. Yeah. It's 1 inch dead according to that. Right, so that was that. That's the standard that I've got. And these Ambrose Shardlow standards, or box. So I'll put that one away. So we know that the micrometer is okay with them, but what's it like with the slip gauge? Our 1 inch slip gauge is here. I don't know what sort of temperature we are in this room either. What are we? We're about 10 degrees at the moment. So we're colder than what we should be if we were in a standard room. I think, isn't a standard room 20 degrees? I don't know what that is in Fahrenheit, but 20 degrees I think here in Britain we're supposed to be. 20 degrees Celsius that is, not Fahrenheit. Well, there you are, we're on 0 again. I'll just show you this without damaging me. The micrometer, it's a bit difficult to show. I'll just try and tilt it down so you can see. Can you see that? Is that registering for you? And there you go. So at 1 inch, it's okay. This is a good micrometer. So as far as the errors are concerned, the equipment, this is not the problem. And the only thing that can be the problem is the operator and the telescoping gauge. You can check this with a 0.5 if you like, because that's in the vicinity of where we're measuring. So let's see what the micrometer's like at about 0.5. So 500 thousandths or half an inch. And what you've got to remember is most of the stuff that I work with here, you know, I'm not working to tenths or anything like that. You know, a lot of you're doing some really precision work, and you've got to make sure it's right. You know, if you were making special shafts or housings or something where you've got to fit a self-aligning spherical roller bearing, or you've got to taper roller bearing, deep groove, single row rigid ball bearings, whatever it is, that type of thing, then SKF and all the other manufacturers will say you've got to make it to this, and then you have to make it to that. So you will be working to tight tolerances. Good surface finish, concentricity, everything. There you go, that's half inch. That's half inch there. I'll let you have a look at that. I'll bring it down, you can see. I mean, hopefully these are actually clear enough for you to see. So that's half inch dead. Or as near as I can actually read it on the micrometer. I can't read too good these days. But anyway, so that's it. I'm quite satisfied that the micrometer's good. It's okay. So when I was doing the testing the other day, this was the telescoping gauge I was using. The reason I was using this was because the one, which is, what's the range of this one here? 5/16 to half an inch. It wasn't working properly. It was sort of jamming a little bit. And I thought, that's not very good. So I thought, well, I'll put that away. Is it at the end of its travel? No, if you feel it, it's not brilliant. These aren't expensive ones. I probably need to invest in a decent set of telescoping gauges, maybe some Warren Wright ones or Starrett or something like that. Get some really good ones. But the one I was using, because I had doubts about this one, the one I was using is the half inch to 3/4, so it's at, where we're using it's at its bottom range. So the thing's nearly closed all the way in, and I was looking at this and I thought, is that a problem? If that's closed all the way in, when you're rocking it backwards and forwards, it's going to hit on the edges, and is that throwing it out? Well, it's interesting. I've just had a quick look at this here, and I've put some of my Starrett oil on, instrument oil on this here. Try to free it off a little bit, but it's not brilliant. I wouldn't like to depend on that. But I think for the purpose of this little test that we're going to do today, we're going to have to work with what we've got. We've got this, then we've got this. Yeah. So we've got the 5/16 to 1/2 inch, and we've got the 1/2 inch to, what did I say, 3/4? Can't remember now. For that one, it looks about 3/4. And let's have a look what the results are. Now remember that first test that we did with the Reamer in the lathe, direct into the quill on the tailstock. We were actually undersized. So I think one of the viewers, Carl, he said that it shouldn't have gone in, and it shouldn't have gone in. The silver steel, which was on dead size at 0.5, should not have gone in that piece of material because it was 1/2 thou under on diameter. So it shouldn't have gone in, but yet it did. So which tells you that it's above 0.5. It can't be below it. So what I thought we would do, let's use this 5/16 to 1/2 inch telescoping gauge first. Let me see if we can get a dimension. It's a bit of an, it doesn't feel, this instrument doesn't feel quite right to me. I definitely think I need to do something about replacing it. Right, let me have a look. That's 1 over. That's 1/1000 over. So if the silver steel was 500 thousandths, the whole of that very first one that we did, that first test we did, is 501. Now we've got a clearance, haven't we? That explains why the silver steel went through. Okay? That's according to this telescoping gauge. Now let's use the 1/2 inch, 1/2 inch to 3/4 one, and let's just see what sort of result we get with that. There you go, it's 1/2 thousandths under. That's the one I was using to do the measuring. It's telling us it's 1/2 thousandths over. So we got 1.5 thou discrepancy between the two, using the two instruments, and I think it's because this one isn't brilliant, I know that. It seems to be sticking a little bit. But because I think this one is closed down, its bottom range of measuring, that's 1/2 inch there now, and it's virtually closed all the way, and when you rock it, it's actually touching on the edges, or it's having an effect on that, or the edges are having an effect on it, so it's not giving us a true result. Just check that again. It's 1/2 thousandths under, and you can feel it just by hand. It just stops straight away when you touch the anvils. I don't know if you can. I'll try and show you this. It's difficult to see. I'll show you so I'm not waffling or giving you some bullshit or anything. Let's see. That's about 1/2 thou under. Can you see that? Does that show up on your screen? It's about 1/2 thou under. So if I use the 5/16 to 1/2 inch one, let's see what that looks like. Check that again, eh? that's 1 over. So there's a discrepancy between these two telescoping gauges that I was using. I think it's because that's closed down to its bottom range, ½ inch. But anyway, so that, I'm happy to say that that first one now, I feel confident enough to say that that is 0.501 inch ball. It's a clearance fit. So there, that's that one. Okay, this is the second one that we did. Remember, we used the floating Reamer holder for this one. We'll do exactly the same with this as we've done with the first one. I'm going to use the 5/16 to ½ inch one. That's going to be like see, this is sticking a bit, that's telling me that's 4 over, that's wrong. Just rock the field. Yeah. It's about 1 1/4 over, that is. It's about 1 1/4 according to this. So this one. This one's about 1 1/4 as well. So it's actually oversized, isn't it? About 1 1/4 thousands over. Knew that was bigger anyway. Right. When we did the drilling and reaming on the drilling machine, which is just behind you. Or 1 and 2. Number 1 was the Reamer straight in the quill on the drill. Let's just check that again. Check that. We'll use the 5/16 to ½ inch first for the first hole. Let's see what that looks like. That's 1 over. That's 1/1000 over. Remember, the silver steel rod passed through, no problem. Let's try the telescoping gauge. See, that's just over 0. So there's a discrepancy there, isn't there? Let's have a look at that second hole, which was the one we did with the floating Reamer hole. Floating Reamer hole, right, okay. That's done, that's 3 over, let's check that again. I say I'm having some problems with this one, it seems to be sticking a little bit. About 2.5 over. So yeah, so if we said 2.5 to 3 thou over. Now let's measure it with this. telling me it's 0. I'm pretty sure it's not 0. Where's my piece of silver steel? Here we are. When we put this in, it's a nice clearance. That's pretty big. You can just about see that. Let me show you. Yeah, see, that's the first hole that we did on the drilling machine, which was the... Let's see, a bit of dirt. See, well, that's a nice clearance. There's a movement there. And that one's a nice clearance as well. It's probably more, you can feel more clearance in that, or movement, than there is in that one. And you can see, even with this is number 1 on the lathe, which is the Reamer in the tailstock on its own. So it's still a clearance. It's a little bit tighter, but it's a clearance. And this is, you know, definitely a running clearance fit. That'd be good for a journal on a shaft. If that was a bronze bush, that'd be nice. All right, so there you go. A little bit of investigation as to where the dimensions came from and the problems that we encountered on. I can't remember what day it was now, probably about 4 or 5 days ago now. But I thought it was important to just verify that the micrometer was okay as far as calibration was concerned, and just revisit the use of the telescoping gauges and why I was using this one. Because this was the one which I wanted to use first originally, the small one, the 5/16 to 1/2 inch. But it seems to be a bit, a bit off. But anyway, I feel more confident with the dimensions we get from the smaller one than we do from the big one, because that's at its bottom range. You know, the two at Landville things need to be sticking out a bit, I think, before you can get a better reading. But anyway, there you go. So I think that was worthwhile looking at. But that's interesting, because that means that all the holes are all over what outside tolerance, too big every one of them was. So just the Reamer in the quill and the tailstock, the Reamer in the quill and the drilling machine, the floating Reamer in the tailstock and the floating Reamer on the drill, all of them were outside, and the floating Reamer was the biggest discrepancy. It was the biggest discrepancy. But that's interesting. I suppose that tells us quite a bit, really. We know what if we needed a good running fit, we know what system we've got to use. If we need a little bit tighter, we can use just the Reamer on its own. And someone commented about a video by Stefan Godsvinter. He's put a video up about lubricants for reaming. Because I'm sure many of you have come across these issues and problems of reaming holes. You don't ream on size. And the types of reamers as well. I've actually got a chucking reamer down there as well. I've only got that one. But do they give you better results than a conventional machine reamer, like the one I was using the other day? I don't know. You'd have to check. But anyway, I thought that was worthwhile doing. I've certainly gained something just by checking this out, checking these out here, the telescoping gauges, and checking the micrometer. So I'm quite happy with that. I haven't got any pin gauges or anything like that, just to clarify what these bores are. All I've got is my silver steel, which we know is 1/2 inch, and I'll just verify that now. It's 1/2 inch. Yeah, it is 1/2 inch. I'll be hollow ground. So there you go. Anyway, I hope you got something from this little video. I shall probably put this up as a sort of a sequel, an addendum to the original one. But it's sort of inspired by the comments from the original video about the floating Reamer holder testing. So I thought it was wise to do this, because it prompted me to think again, and that's the importance of comments. You know, the comments are as important, just as important, if not more important than perhaps the video itself. Because what you've got is many people out there, like you people, have got knowledge and experience of engineering, and you're putting that information down, you're typing it in your computer, you know, on the keyboard. It's available for everybody then, and it prompts people to think, recheck things, or change the way they do things. So that was great. So thanks very much for everybody for the comments. I do appreciate that. But anyway, it's time for me to get on to something else, and I'm doing some work on the vacuum brake cylinder pivot bearings today for the tender. So I'll get on with them and I'll leave you alone. Alright, thanks for watching, and I'll see you again.